On this video, we will be looking at current. So how can we control current? With circuits. A circuit is defined as a path for the flow of electrons, and we can use wires to accomplish a circuit. There are two types of circuits. There's the direct current circuit, known as a DC. This is where the electrons flow in the same direction. If this was animated, what it would be showing you is that this is flowing in this direction like that right there. Examples of direct current would be batteries, lightning, and static electricity. With lightning, it's a form of a DC current. It's produced by static electricity in clouds. The static is formed when air molecules move past each other, just like clothes move past one another in a dryer. The other type of current is an alternating current, or an AC current. Here the electrons flow in different directions in the wire. So they can flow in this direction for a while, and then they can flow in that direction for a while. Examples of AC current would include things such as household outlets. They reverse the direction of the current about 120 times per second. So an electric current needs components. It will need a source of the electrons. In a DC current, this will be a battery. In an AC current, this would be a generator. The circuit will also need a load or a resistance. This is going to be the device that uses the electrical energy. It's what offers some resistance to the flow of electrons. The circuit will need wires and switches. This will allow it to open and close the electric circuit. Now remember, electricity can only flow through a closed circuit. If a circuit is open, the electricity flow will halt. So that an electric circuit is a pathway along which the electric current can travel en route to the device. Locating a device along that pathway will allow it to be powered by the electric circuit. There are two different types of circuits. There are series circuits and there are parallel circuits. So that when a charge moves across a potential difference, its potential energy changes. Therefore, the power it takes to do this would be power equals current times voltage, where the units of power are in watts. Now, in a problem, if you were given the power in kilowatts, you would need to change that over to watts in order to solve the problem. If we look at energy and power in a circuit, I did give you this formula earlier. Power equals current times voltage. Now, if we needed to find a problem where we have current but we do not have voltage, power can equal current squared times resistance. We also have power equals voltage squared divided by resistance. So three equations that I would have you write down on your chart would be right here, power equals current times voltage, and then right here, power equals current squared times resistance, and then this one right here, power equals voltage squared divided by resistance.